Hello everyone, this is Y. Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. So today we are going to discuss about the next concept, functional dependency in database management system. So functional dependency in database management system. In the previous sessions we discussed about different types of attributes, different types of models, different types of relational models, design issues and everything. So in this session, we are going to depending of all the attributes, how they are dependent to each other on the tables, on the entities. We'll see how those attributes will work for the functionally dependent on tables. So the functional dependency. So functional dependency is a relationship that exists between two attributes. So two attributes. So there must be a relationship between two attributes. So that is called as functional dependency. So it exists between two attributes. The relationship exists between two attributes. It typically exists between the primary key and a non-key attribute within the table. So primary key and non-key attributes. So in the table we are having a different types of keys. All other attributes are depending on one attribute. So that attribute is nothing but primary key attribute. Suppose you can take the student table. The student ID is one attribute, student name is one attribute, and the student city is one attribute, student marks is also one attribute. So all these are all attributes depending on one attribute called as primary key attribute. So from this table, from this student table, we can say that ID is a primary key attribute. ID is a primary key attribute. And other student city, student name and student marks are non-primary key attributes. Non-primary key attributes. So we shows that these dependent attributes are on depending of ID attribute. We will represent it in the form of x tends to y. X tends to y. From this x tends to y, we can say that ID is the x value and remaining all other attributes are y values. So this x is said to be a determinant value. That means the left side of functional dependency is known as determinant and the right side of the production is known as dependent. That means all the y columns, all the y attributes, name, city and marks, these are all the dependent attributes. They are depending on the primary key attribute. Without having the primary key, without having this ID, we are not going to retrieve the values of these columns. So assume that we have an employee table with the attributes employee ID, employee name, employee address. Here, employee ID attribute can uniquely identify the employee name attribute of employee table. Because if we know the employee ID, we can tell that employee name associated with it. That means if we know the employee ID, we can say that employee name, employee salary, employee city, employee department, everything. But without knowing of employee ID, we cannot say the name of that employee, salary of that employee and department of that employee. So that if you want to fulfill that all the fields, we have to fill that primary key field. So that functional dependencies can be written as employee ID tends to employee name. That means this employee name is functionally depending on employee ID attribute. So here from this employee ID tends to employee name, the employee ID is the determinant attribute and the employee name is a non-determinant, that means a dependent attribute. So we can say that employee name is functionally dependent on employee ID. So from this example, from this definition, we can say that the attributes are depending on one attribute. That attribute is called as primary attribute or primary determinant attribute. We can say that it is a determinant attribute. And all other attributes, those who are depending on other attribute, those are called as non-determinant attributes. That those are nothing but dependent attributes. attributes. Dependent attributes. One is determinant attribute and the second one is a dependent attribute. Right? And from this determinant and dependent values, we can have different types of functional dependencies. One is a trivial functional dependency. So from the functional dependencies, we can have divided into two types. One is the trivial functional dependency and the second one is non-trivial functional dependency. Non-trivial functional dependency. So we'll see what is meant by trivial functional dependency. So A tends to B has a trivial functional dependency if B is a subset of A. If B is a subset of A, the following dependencies are also trivial, like A tends to A or B tends to B. That means the subset of the second table or second attribute is a subset of the primary attribute or primary table. Then it is said to be trivial functional dependency. We will see the example. So consider a table with two columns, employee ID and employee name. So the employee table can have only two columns, employee ID and employee name. So the set employee ID, employee name belongs to employee ID is a trivial dependency. We can retrieve the value from both these. We can retrieve the value employee ID from these both. So employee ID is a subset of employee ID, employee name. So employee ID is a subset of employee ID, employee name. That we are having the primary table or other non-primary table. Also, employee ID belongs to employee ID. So if we have employee ID column in the table, then we can retrieve the values of employee ID. And similarly, we can have the employee name and employee ID columns in the table. We can retrieve the values of either employee ID or employee name. But we cannot retrieve the values of salary without having the column names in the employee table. So that is said to be trivial functional dependency. If the column names have existed in the table, that we will retrieve the values either employee ID, either employee name, either any of the column that existed in the table. So similarly, employee name or employee names are also trivial dependency. So among employee ID, employee name, we can retrieve either employee ID values or either employee name values, but we cannot retrieve the values of salary because the salary column is not in the employee table. Suppose you can write employee ID, employee name, employee salary from the table of employee. Then you can say that it is a trivial functionally dependent on employee ID or employee name or employee salary. So that you can write it as employee ID, employee name, employee salary. So this is a trivial functional set belongs to, you can take any of the value, employee salary or employee name. You can retrieve any of the value. If it exists in the table, then you can retrieve the values of employee ID or employee name or employee salary. But they are trivially dependent on that employee ID also. They are trivially dependent on employee ID. So that we will retrieve the values. So this is a trivial functional dependency. And non-trivial functional dependency. So A tends to B has a non-trivial functional dependency if B is not a subset of A. If B is a not subset of A, that means the employee ID and employee name, employee ID, employee name, these two are belongs to employee table. So from these two values, you are going to retrieve the employee salary value. It is not possible because employee salary column is not in the table of employee. The employee table can have only employee ID or employee name. But you are trying to retrieve the value of employee salary from the employee table. So that it is not possible because they are not depending on employee ID or employee salary. Because that employee salary is not existed in the employee table. So that means A tends to B has non-trivial functionally dependent. If B is not a subset of A, that indicates that value is not in the table. So when A intersection B is null, then A tends to B is called as a complete or non-trivial. Then A tends to B is called as a complete non-trivial. So example, we can see. So if we are having the ID of the column from the employee table, we cannot retrieve the name value. Similarly, we can have the name column from the employee table. We cannot retrieve the date of birth of the employee because these are all non-trivial functionally dependent. Non-trivial functionally dependent on other attributes. Suppose if you are taking ID, name, date of birth, along with these values you are going to retrieve date of birth, then you can say that the date of birth attribute is trivially dependent on this ID, name. But here that attribute is not there. DOB, date of birth attribute is not there. So that means it is non-trivially functionally dependent on these columns, these attributes. So that is a non-trivial functional dependency. So functional dependency is concept only for the attributes, those who are having the dependency of the tables. Those who are having the dependency of the tables, those primary key or non-primary keys. The determinant attribute and the dependent attributes. So all other attributes are depending on one attribute is called as determinant attribute, and other attributes are called as dependent attributes. So this is about the trivial functional dependency in the DBMS. Functional dependency or non-trivial functional dependency in the DBMS. So by applying this all the dependent values or non-dependent values, we are having some rules. Those are also called as Armstrong axioms. Armstrong axioms. So we can say that inference rules are Armstrong axioms. So what are those and where we are applying them and what is the purpose to apply them on the tables? We will see in the session. So the Armstrong axioms are the basic inference rules. Basic inference rules. So Armstrong axioms are used to conclude functional dependence on a relation database. So the attributes, how they are depending on other attributes and how they are functionally dependent or functionally dependent or determinant. So we will these Armstrong axioms are used. The inference rule is a type of assertion. It can apply to a set of functional dependency to derive other functional dependency. And using this rule, we can derive additional functional dependency from the initial set. So we are going to validate that attributes are functionally dependent on other attribute or not, and how that attributes are dependent for another attributes. So we have to validate those functionally dependency concept by using these inference rules. So these rules are having some logical assertions. So we'll see how it is called. The argumentation is called as a partial dependency. In argumentation, if x determines y, then xz determines yz for any z object, for any z attribute. So the argumentation is called as a partial dependency. In argumentation, if x determines y, then x determines yz. So if x determines y, then xz determines yz. For any z is another attribute. So suppose x is having id attribute and y is having name attribute. So id, salary attribute tends to name, salary attribute. So this salary attribute is functionally dependent on id, salary attribute. So this is a trivially functional dependency, so that it is a valid argumentation and valid statement. So that is nothing but partial dependency from xz determines yz for any z is another attribute. So now we are applying the rules for validating that functional dependency. So the rules are having the formation like in the reflexive rule. The first one is what? Reflexive rule. That is also said to be inference rules. We can call it as IARE1. So in the reflexive rule, if y is a subset of x, then x determines y. If y is a subset of x, or subset of y, then x determines y, we can call it as. So that means that any of the attribute from the x is a subset of y, or y is the subset of x, then x determines y. So symbolically we can determine as if x subset of equals to y, then x tends to y. So example, if x having the values a, b, c, d, e, then y having a, b, c. That means indirectly this y is a subset of x, or x determines y. X determines y. So this is one rule that applies on the attributes of the table. And second one, augmentation rule. Second one, augmentation rule. The functional dependency has 6 types of inference rules. The functional dependency has 6 types of rules. So one is if x tends to y, then xz tends to yz. So if x tends to y, then xz tends to yz. That is what we discussed in this previous sessions, previous minutes. So if for any table, a relation of a, b, c, d, if a belongs to b or a tends to b, then ac tends to bc. AC tends to bc. So then it is said to be augmentation rule. IR, it is satisfied. And next one, transitive rule. IR 3, inference rule 3. The transitive rule is said to be if x determines y, if x determines y and y determines z, then x must also determine z. So x must also determine z. So this is called as a transitive rule. And the union rule, IR 4, you can say that inference rule of 4. So union rule says that if x determines y and x determines z, then x must also determines y and z. X must be determines y and x determines z, then x must be determines y and z. X determines must be y and z. So that is nothing but union rule. So that means the attributes from the y table, attributes from the z table must be satisfied with the x table. Must be satisfied with the x table. And next one, decomposition rule. So decomposition rule is also known as project rule, and it is the reverse of union rule. So it is the reverse of union rule. So in union rule, what we said, if x determines y and x determines z, then x must also determines yz both. So decomposition rule is the inverse of this union rule. So what we have to say here, it is the reverse of union rule. The rule says if x determines y and z, if x determines y and z, then x determines y and x determines z separately. Both are separately. So this is the decomposition rule. And the pseudo-transitive rule. This is the inference rule of 6th one. And in pseudo-transitive rule, if x determines y and yz determines w, then xz determines w. Then xz determines w. So here, what we have to understand here, if x determines y and yz determines w, then xz belongs to w. Xz determines w. So this is the pseudo-transitive rule. So these all the rules are applied for only to validating the attributes functionally dependent on other attributes or not. So if all these rules are satisfied, then the attributes are said to be the functionally dependent on primary attribute or dependent attribute. Or otherwise, you cannot say that these are functionally dependents. So we can say that it is a non-trivial functional dependencies also, right? So these are all the rules for applying on attributes to say that it is a valid functional dependency or not. It is a functional dependent or not. The next one is what? Normalization. The concept is what? Normalization. So normalization is the process of organizing the data in the database. So normalizing is the process of organizing the database. So organizing the data. So data is different and database is different, because data is a placing item and database is a place where the location item. So you are going to place this data into the database. So the process of organizing, how that data is to be organized, how the data is to be placed, how the data is to be structured, how the data is to be arranged, everything we can say that in the form of normalization. So that why we can say that normalization is the process of organizing the data in the database. So normalization is used to minimize the redundancy from a relation or set of relations. So normalization is a process of organizing and structuring, or what we can say, whatever we can say. Normalization is used to minimize the redundancy from a relation or set of relations. That means from a table or set of tables. So you can minimize the redundancy. Redundancy is nothing but duplications. The duplicate values that are inserted in the table is going to be minimized by using this concept. So it is also used to eliminate undesirable characteristics like insertion, update and deletion anomalies. So from this insertion, update and deletion anomalies, from this insertion, update and deletion operations, whatever the conflicts or anomalies we are getting, we have to eliminate that undesirable characteristics. We have to eliminate that undesirable characteristics also. A normalization divides that larger table into smaller and links them using relationship. So that means normalization divides that the larger table is into decomposing the different types of tables, so that it is said to be a smaller and links them using relationship. So they can divide the table into relationships, and after that decomposing all the tables are going to be merged as a single relationship, as a single relationship. The normal form is used to reduce the redundancy from the database table. Normal forms, we can use the normal forms, different types of normal forms is used to reduce the redundancy from the database table. And what is the purpose? What is the purpose to do we need normalization? So what is the purpose to do normalization actually? The main reason for normalization, the relation is removing these anomalies. The main reason for normalizing the relations is to removing the anomalies. The insertion, updation, deletion, having some conflicts, having some disruptions. So that anomalies, we are going to eliminate them. We have to eliminate them. And failure to eliminate anomalies leads to data redundancy. So failures of the anomalies is going to lead for data redundancy and can cause the data integrity and other problems as the database grows. So whenever the database is growing up, database is having a lot of data, automatically this insertion and updation, deletion anomalies will increase, so that the database integrity and the consistency losses. So to do not lose that integrity and the consistency, the database is going to minimize that anomalies of insertion and deletion operations. So to do that, we have to do the normalization. To do that all, we have to do the normalization. So normalization consists of a series of guidelines. Normalization consists of a series of that guidelines that helps to guide you in creating a good database structure. So to avoiding this all things, we have to consider that some of the guidelines that will help you to form the structure of the database. So however the structure is going to be have the database is going to be inserted. The data is going to be inserted in the database because of the structure. The anomalies or redundancy problems will occur. So the structure of the database is having a very good, then the anomalies of database insertions or database deletion anomalies will be minimized. So that we are going to use this normalization concept. So to do that, to reduce that anomalies, to reduce that integrity problems, we are going to use that concept normalization. So what are the different types of anomalies will happen without having this normalization? So data modification anomalies can be categorized into three types. So one is insertion anomalies. So insertion anomaly refers to when one cannot insert a new tuple into a relationship due to lack of data. So without having the data, we are going to insert the values. Without having the data, we are going to insert the values. So that is one insertion anomaly. That is one mistake. Without having the data, we are not going to insert the data in the database, right? So that is one insertion anomaly. That refers to when one cannot insert a new tuple into a relationship due to lack of data. Without having the data, you are not going to insert the value. So that is not also taking that insertion operation without having the data. So and second one, deletion anomaly. So delete anomaly refers to the situation where the deletion of the data results in the unintended loss of some other important data. So if you are doing particular deletion operation of all the data, so some of the data is intentionally it is lost. So that we are going to delete the data particularly required. So whether it is required to delete the data, then it is very easy to do that. But you are not going to do all the data is to be going to delete it. So that is one deletion anomalies will occur at the time of deletions operations. And update anomaly. So the update anomaly is when an update of a single data value requires multiple rows of data to be updated. So without mentioning of any where statements or without mentioning of any conditions, you are going to update the value so that all the updations, so that update value is going to update all the values in the table. So by mentioning the conditions, only, you are going to update the particular value, So that we are saying that this is also updation anomalies. So to avoid this all the anomalies, to minimize this all the anomalies, we are going to minimize this all the anomalies. We are going to have some we are going to have the normalization process. So these all the anomalies we have to reduce, and to reducing that all these anomalies, minimize the concept of normalization. So what are the advantages of normalization? What are the disadvantages of normalization? So by doing this normalization process, so normalization helps to minimize the data redundancy. So minimize the data redundancy. Redundancy is nothing but having the duplicate values in the database. So to avoid that duplication entering the values, to avoid the duplication entries, we have to do this process, normalization process. And a greater overall database organization. So by creating the database structure, great organization, great process, great formation, we can have this normalization very easily. So that it helps to minimize the different types of anomalies what we discussed in the previous. And data consistency within the database. Automatically the anomalies minimizes the data data is going to be very consistent in the database. And a much more flexible database design. So whenever you are having the flexible structure of the database, so that you are going to design a particular database is to be very efficiently. So that if the structure of the database is very good, then the design is also good. So that helps to minimize the anomalies or minimize the redundancy problems, minimize the integrity problems and everything. And enforces the concept of relational integrity. So the relational values. So for like foreign key integrity constraints or primary key integrity constraints, those are also by applying them we can reduce the duplications also. So this is also one advantage from the normalization. And what are the different types of disadvantages? So we cannot start building the database before knowing what the user needs. So to do the normalization process, the developer or designer must have the knowledge of different needs of the user. Different needs of the users he must know. Without knowing of the user needs, they are not going to design a good database. So you cannot start building the database before knowing what the user needs. And the performance degrades when normalizing the relations to higher normal forms. The performance degrades when normalizing the relations to higher normal forms, like 4th NF or 5th NF. So the performance is going to be decreasing whenever you are taking the multiple number of normal forms or higher normal forms, and it is very time consuming and difficult to normalize relations of higher degree. So whenever we are having a lot of data, that is a high amount of data, so that it is very time consuming and difficult to normalize the relations, normalize the tables when having more than thousands of variables in the database. And next one, careless decomposition may lead to bad database design and leading to serious problems also. So whenever you are doing decomposition of the tables, after that decomposition, you do not go to lossless decomposition. So after that decomposition of the tables, we are going to have some problems. So that means the careless decomposition, if you are not decomposing properly, that leads to some different types of problems. So that is also a disadvantage of normalization. That means these are all not a disadvantage. These are all some certain limitations that we have to take care. That limitations of that database needs. So as soon as the database having the higher amount of data, the database design should be very difficult, and the database having some serious problems also, right? So this is the way we can understand that normalization. What is the normalization and what we do in the normalization actually? So this is what we discussed in this session. So we'll see once again what we discussed in this session. So the first one is what? The functional dependency. So what is meant by functional dependency? So the attributes are depending on another attribute. So the dependent attribute and a determinant attribute. So from these attributes we are going to take all the attributes and what all the attributes are depending on another attribute. So that is functionally dependent. And there are two types of functional dependencies. One is trivial functional dependency and second one is non-trivial functional dependency. So trivial functional dependency is nothing but any one of the attribute is a subset of the main relation attribute, so that it is said to be trivial functional dependency. And the other side, it is not able to subset of the main relation attribute. And to validating these all functional dependency values, we are going to use some inference rules or Armstrong axioms. So the different types of Armstrong axioms. One is reflexive rule, and second one is augmentation rule, and third one is transitive rule, and the fourth one is union rule, and the fifth one is decomposition rule, and the sixth one is pseudo-transitive rule. And these are all some rules, inference rules that validate the attributes. Those are all having functional dependent or not. And the normalization. So what is meant by normalization, and what is advantages, disadvantages, and why do we need normalization actually? So these are the topics we discussed in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.